Okay, we're going to walk through a KStreams application that enriches some data and puts it into another stream. In this particular use case, we have some data that's coming from mobile devices, and we want to ultimately aggregate the number of octets and packets by time. And we want to calculate a few things. Now, what's interesting about this data is that it's not it doesn't include the data in real time each time. It includes a cumulative total each time. So we'll have to kind of compute the delta by taking what the previous total was and subtracting it. So if you can imagine, a session would come in, data would be coming into the stream, and then we would be enriching it and putting it into another stream. We'd use a Windows store to help us figure out which one was the previous one. So at a high level, that's what it does. And the way we'd be doing it was we'd be using a Windows store, and we would store each time a record comes in. We would look up previous timestamp, put it in, pull it out of that, use it to augment the data, and then we'd put this one in to that store as well, and then it would move on. Now, it's a little bit more complicated than that because actually these can come out of order. So that would be fine for the moment that that one comes in, but then the minute another one comes in, say that there's a record that comes in that actually is in the middle of two that already came in, well, we would need to look up the previous timestamp of that one and compute it and drop it into the stream. But we'd also need to look up the one that came after it and recompute that one, because that one would have had the wrong previous numbers. It would have had the one for the one before it. So we would want to make sure that we recompute it and drop it into the stream. To do that, we'll use a flat transform, which lets us emit more than one record. So you won't always get one record, but more than one record. You will get two records if they do come out of sequence. Okay, so let's take a look at how this is done. So a quick code walkthrough. We've got an application here that we would just run from the console effectively, and then from there we've got this. We build a topology. This is the normal way that we do it. Our topology has in it the source stream, so wherever this data is coming from, that was that top arrow. Then we would move that so we can see it. Okay, we would have the top arrow. Then here, the supplier is our flat transform supplier that does the work of creating two records, and it does the work of looking up. But that's where this is kind of wrapped in the stream. We build a store for it, and we're going to give the transform supplier this store. So in other words, we tell it, I want you to store it in here, and you use it. You do the lookups and everything, but here's the store for you to use. We add that to the builder, and then finally we execute the flat transform, and then we finally drop it into this enriched stream produced with, and this is how we serialize it. This is code that tells us how to serialize and deserialize it. So if you look carefully, we serialize the source with this source record, and then we deserialize, we serialize the enriched one with this enriched record, which has several new columns in it. It has the previous column. So this one will have the current records. This one will have the previous and the deltas in it. We also computed deltas because we figure it's there. We might as well use it. So if we were to see, yeah, that's pretty much it. Now let's take a look at the flat transformer. All transformers kind of have the same signature. They have an initialize, and they have a close, and then they have a transform. What makes flat transform different is that it returns an iterable. So it returns a list, effectively, something we can walk through, of key value pairs. So our key value pairs are this, we're going to return a list of keys and enriched. We're going to take a list of keys and original. And then here's the code, effectively. We'll figure out what the timestamp of the current context is first, and we'll run a little computation to figure out what our windows should be. We have a little bit more fine-grained control over this than maybe you would in KSQL. And we're going to pull the key out, and just for simplicity's sake, we're going to use the MC. We could make it anything we want. We can make it composite. This is where we're actually making the key. So it can be, since we're writing code, anything we want. But let's just keep it simple and just say it's the MZ. Now we're going to fetch from that Windows store, which is backed by RocksDB. And we're going to fetch this key on this window. And then we're going to start iterating. First thing we're going to see is, let me get the timestamp of the current record in the store. Now, if there is nothing in here, it's going to immediately just short circuit this loop, come down and add the record into the store. It's going to run this little enriched with helper function here, which you can see if it takes a null new record, it's just going to add zeros in the previous, and so the delta will be whatever the current record is because of this computation. So 0 would be previous for the first time you ever saw this key, which makes total sense. That's fair. However, if there are records, if there is one, it'll iterate through. And remember, these aren't going to be stored in any order, so we have to iterate through all of them. So we're going to continually do kind of a king of the hill algorithm in reverse if we're going to keep trying to find the previous record. So basically, if the record is between the current previous and me, then you are the new previous, and we're going to keep doing that. We also want to do the same thing for the next, just in case there is a record that came out of this and I came out of order. When we're done iterating through all of them, we come down to here. And what we're going to do is we're going to add the previous, we're going to enrich it and put it into the set. So we're going to return this. What's returned then is what is transformed and sent to the enriched stream. You return from the transformer, and then KStreams will handle putting it in the .2 later where we said it would be. If there's also a next, we will do the same thing. We will enrich what the next one should be, basically effectively updating it and dropping it in the stream. And that's it. Then we return that result. Okay, so let's see it run. So first thing we're going to do is we're going to go over to our version of Control Center, and we're going to look at the cluster. And this one's empty. We haven't done anything to it yet. So we're going to emit some topics. So emit some data into a topic. So taking a look at Postman, just to see what we're going to send. We're going to send these 5 records. Now these 5 records represent some timestamps. And one of them, by the way, one, maybe 2 are out of sequence. But as you can see, what happens is I'm going to emit them to this schema, which with this schema is the enriched event EDR, the first, the entry schema. And if you look at what it looks like, you'll see that there are these octets in here and packets. There's no deltas or anything, because that's not that schema. That schema is the result schema. So what we're going to do, if we take a look at the parameters of this query, we're going to send it to the RESTful server. And on this part, this is just for testing. You could do, you're going to emit data any way that you want to, but in this case, I'm just trying to show that we're going to emit these 5 records to a session, to a topic called PL session event EDR. Which kind of corresponds to what this is called. This is called PL session event EDR is also the name of the record. Should sound familiar. That's our input. And then we're just going to emit these 5. So we'll just send them. Okay, they ran. Come over here. We see a session popped up, a topic, Click it. And let's go look at and see what's in it. Starting it off at offset 0. Remember that it's going to start at whatever offset when you open this window. So we just want to say 0, and we got them. We got 5 records, and if we look in here at the data, we'll see. You can kind of, there's some intuition here. You can change these from Unix to strings to kind of understand them, but there's a little bit of intuition here as to what it did, and we can see that they go in numerical order. So you can see that some of these are in and out of sequence. So this is the timestamp we're interested in here. 200756. This one actually is out of sequence then, right? This one came before this one. So we look at the data and we'll say, okay, yeah, I see what's going on. They're kind of in increasing order for the most part. Okay, so this is good. So now what we want to do is we want to run the application, and we should get a new topic. So let's go ahead and do that. We'll run it. Okay, it's going to take a second to compile. So what it's doing is just setting up a Java app. It's going to compile, run, and then execute. So we're going to let that happen. Okay, now we see some new streams. Okay, we see two new streams. And the two streams are this. We've got this enrichment my store changelog. It's called this actually because I have a configuration file in resources of this project. I'm sorry, in config here. And what did I name my store? I named it my store. What did I name my application ID? Session enrichment. So you can see if you change these variables around, you can kind of control what it's named. But that's what it's named. Inside here, you will see that this has some messages, and its messages are actually the backing for that window table. This is what's actually, so if you drop that window store, this data would be able to recreate it next time I rerun the application. Conversely, if I want to reset all that state, I need to delete this topic. So that's what that topic is. The one of interest, though, is this enriched stream topic. So if we take a look at what's inside of it, we see we've got several in here. Okay, what happened? So what is this topic actually showing us? Okay, we can see here that there's some interesting things going on. This is the first record here that came in, and it had no previous, so it's got computed that way. And you can see some of these kind of came in and as they were computed, but then you can see the same timestamp was then recomputed, because then the subsequent record got put in right order and it computed its correct delta. So if you were to look at the last versions of each of these, and I kept the event time, the timestamp of when these things actually came in, just so that we could see it, right? Create time, just so that we could see this. If we didn't do that, which would be fine, we could use the event time of the record, but we wouldn't see necessarily all of these, kind of changes. But as you can see, this record here, it has an event time of, this one's 70. This one's a 6670. I mean, sorry, 67200. This one's a 702. This one comes before this one. So what happened is this one came in first. Yep, has no previous, so the deltas are itself. This one here came in. It had one previous, so it subtracted one. So you get these deltas, and so on. You can see then that if we look down here, some of these other ones that were put back in sequence. There's some zeros here, but you can see that they were put back in sequence properly. And that's it. That's all there is to it.